Hi everyone! Today we are going to walk you through a quick demo of our project. Our team has been working on a color identifying web application called TrueSight. The main function of TrueSight is to process images uploaded by the user and then accurately identify the colors within that image. Our target audience is colorblind or visually impaired individuals that can use our site to help differentiate between colors in an image. Some common use cases for this could be transportation maps like color-coded bus and train routes, or statistical charts and graphs that use color to convey meaning within the data. Now onto the actual website. So this is the main homepage for our application. Here we have some simple instructions on how to use the color identifier. As you can see, a user can optionally select a specific type of color blindness, red, green, or blue, yellow, and our system can take this information into account when processing the image. Next, the user can select their chosen image file and upload it using these buttons over here. At the bottom of the screen, we've also included a mini example to give users a visual idea of how the application will process their original image and output a modified version that they will be able to interact with. Now, accessibility has always been of the utmost importance to our project, and as such, we have made a priority of implementing accessible design features. One such example can be found in our general navigation of the site. Users with a screen reader or those that rely on tab key navigation instead of the traditional mouse click can fully access every part of the site. On the main homepage, they also have the option to skip over the navigation header and jump to the main content to improve their ease of use with the site. Now I want to draw our attention to the three main subpages that the user can navigate to. First, we have the About page, which includes additional information for the user on our website's mission statement, as well as our privacy policy that assures the user of our application's data collection and storage. Next, we have the How to Use page that lists our best practices for the user when uploading the image of their choice. We have some general guidelines here on factors that may affect the functionality of our application, such as the brightness of an image, the image quality, or the general formatting of the image. Finally, we have the FAQ page that answers some of our most commonly found questions about both the functionality of our site as well as our general goal to assist individuals with color blindness. Overall, we wanted all three of these subpages to act as a helpful guide for potential users by answering their questions and including clear instructions and documentation that they can reference throughout their use of the site.
Now we will show the different features of our website and demo with some different types of images. We can either select red-green color blindness or blue-yellow color blindness to modify the image to make it more visible to people with that specific type of color blindness. Or you can leave that option blank and then choose an image to upload, which will make grayscale, and then you can select which color you want to isolate, and it'll end up like this image. First, we can demo the different color blindness options. Here, I will select the red-green color blindness option, and now I can upload an image. The image I'm selecting here is actually a test for people with red-green color blindness to tell if they have it. And if they do have it, then they wouldn't be able to read the number on that image. But if we click upload, this modified image now allows people with red-green color blindness to clearly read number 74. And we were able to confirm this with one of our group members who has red-green color blindness, and it works, and he's able to see this clearly now that the image is modified. But the goal of our website is more aimed at helping people read maps and charts than just to decipher color blindness tests. So we can navigate back to the home page to test this feature on a map. So we can select the red-green option again, and then go to choose this bus map and upload it. And then this modified image makes the different routes much easier for a person with red-green color blindness to see and to distinguish between. Next, I will show how you can use our website if you don't select one of the specific types of color blindness. So we can navigate back to the homepage here, and we can go to choose a file, and I'm going to upload this TV screensaver since it has a bunch of different colors in it. And then we go to upload it, and first it gives us this modified image, which is completely grayscaled. And then if we scroll down, we have the original image here, and you can select one of the different colors on it. And as you see, the RGB value changes depending on which color you click on. But so if we click on this magenta color and then go to isolate this color, it gives us the modified image here where all the magenta in the image is completely isolated while the rest of it is grayscale. And then we can do this as many times as we like. To scroll back down here and as the original image, you could click on a different color. We could do this yellow, isolate this color. Here's the yellow isolated. We can do it again. Click on the screen here, isolate it. So you can do this as many times as you want. Now we can go back to the home page and demonstrate this with a few other types of images, such as the maps that we intend for users to use this website more for. So first we can go and choose this map image. You can note that this image here is a JPEG file. The rest of them so far have been PNG, but we accept different types of image formats. And then we go to upload it. Here is the grayscale image again. And then I can select this purple color here, isolate it, and it isolates this purple route on the rest of the grayscale image. And then we can go home. We can demonstrate this one more time. Could choose a file. We can do it on this subway here. Upload it. Once again, here is the grayscale image. And we can select this red route to isolate and isolate this color. And then here is the image with just the red route isolated. Or we can, again, click on, we'll do the green route here, isolate this color, and it is isolated from the rest of the grayscale image.
For our project, our group decided to make two Python files, one for our API and one for our image manipulation. For our API, we decided to use the Flask package, and for our image manipulation, we decided to use the Pillow package. For our API, our first four routes are static routes, those being the homepage, the about page, the how-to page, and the FAQ page. There is nothing dynamic to display on these since they're mostly just instructions and text, so these are pretty easy to implement. Our next route is our upload route, which our user will call on the homepage once they upload an image, and also if they select a colorblind option. We get both the image and the colorblind option here using the syntax. We then save the image that the user uploaded, run it through our keep one color function, and then return the format of this keep one color to the results page in order to display the image dynamically. Our next endpoint is the re-upload endpoint, and this is used when the user wants to isolate a different color on an image that they've already uploaded. So instead of uploading the same image over and over, they can just use this re-upload route, which makes their results come faster. So we get the RGB value of the color that they would like to isolate, as well as the format of the image, just to make sure that our image formats are consistent. We then run it through our re-upload keep one color function, which returns a image format, and then we, similar to the upload one, we redirect that to the results page, with the format being a URL argument. The last API route is the results page. This is where we display our modified images to the user. We do this by getting the image format as a URL argument, and we do this dynamically because we accept PNGs, JPEGs, and also HEIC images. And since we're using HTML, we need to know the extension of the image before we display it. So we do that by passing it in, which we can then concatenate and call one of these images that we have stored. So those are our API endpoints. The next file is our image manipulation file. We use Pillow for this. Our first function is where we implement our color blindness palette logic in case the user selects the red-green color blindness option or the blue-yellow color blindness option. We do this by converting the image to an array. And then if they choose blue, yellow, or red, green, we create a modified matrix multiplier for each channel. So this being the red channel, the green channel, and the blue channel. And we multiply each pixel by these. So for example, in the red-green one, we have the green channels, these middle ones here, be lower than the other channels, since we're trying to lower the amount of green used in the image, which will help make the image less ambiguous to the user. We do this by using the dot product of the image and the matrix. We then clip any values that are higher than 255, turn the image back to a JPEG format, save it to be displayed, and then return the format that we saved it as. The next function we use is the set tolerance function. This function allows us to handle different formats of images that users can submit. For example, PNGs will take a 10 tolerance, while JPEGs will take 50. This is because JPEGs are compressed and therefore are not able to display as many colors. So we need to use a lot of tolerance in order to get a fully encompassing result to the user. And then HEIC is somewhere in between the two with a tolerance of 20. And when I mean tolerance, I'm basically meaning a plus or minus value to apply to the RGB values of the pixel the user selected. So we get the red upper bound and the red lower bound. And so these are basically, this is a range of red values that we will accept when we use our image isolation. So once we find the tolerances, we will then convert the image to a grayscale. And then we will go through each row of the image and select each pixel and get the color of that pixel. And if the pixel is within the range of our bounds, we will color that in the mask image. And we do that for every pixel. Once we're done with that, we will create a composite image with the grayscale and the mask image, which will then return an image with that color completely isolated, with the rest of the colors in that image being grayscaled. We save this image to be displayed. We get the format, and then we return the format to our API to help dynamically display the image. We also have our re-upload keep one color function. This function takes in the RGB values that the user inputted in case they want to isolate another color in an image they've already uploaded. So we get these values, run it through our tolerance function based on the format of the image, get our bounds, and then run through the same logic with masking and grayscaling and using the bounds to color in the pixels to get our isolated color, which is here. And then we save that image to be displayed and return the format to our API to help dynamically display that image. Our last two functions are for saving the images. This function is used on the home page. For the first time a user wants to save an image, we can dynamically do it using this ifs and else statement. And then this function is when a user selects the colorblind option and wants to further isolate colors after editing the image to account for color blindness, which is done here in the process image. But yeah, those are our two files that make our website and image manipulation possible.
Working on our project, we have faced numerous challenges. The main challenge for this project was staying on track of what we planned. It was challenging because we had made plans so early and we didn't know what problems to expect and what challenges we were going to face. Even though we tried our best trying to stay as what we planned initially, it was hard to follow the Gantt chart we had planned perfectly. The main problem for the Gantt chart part was planning. At first, we thought we would be able to finish planning and start coding earlier, but the planning took a way longer time than we expected since our plans kept changing as we progressed. We were mostly on the track, but we definitely had a period of us being ahead or being behind than the planning. We also made sub-teams expecting to work on separate things. Serena and Kyle were chose to work on the website, and Maggie and I were chose to work on the computer vision part. But we ended up working on different things as we progressed, since we realized that we were lacking in knowledge in computer vision and didn't have enough time to learn and work on this project. There was also an image that had a bug that we couldn't get to fix. For some reason, the image was not changing colors like it was supposed to, and we couldn't figure out the issue. It was weird and hard to fix because it was working for the other images, but it was not working for the specific image. This was the only bug that we could not get a resolution. Despite the initial difficulties in sticking to our plans, our team's determination and hard work paid off. We managed to overcome obstacles and adapt to changes, ensuring that our project reached a successful conclusion. While there were bumps in the road, such as the unresolved issue with the image, that didn't overshadow the overall success of our project. Our ability to work together effectively through the challenges resulted in a satisfying outcome.